Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wellness. Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're gonna continue our multimeter series and I'm gonna today try to do something a bit different. So today we will start understanding something very simple. Multimeters are generally divided in two core criteria. Criteria number one generally would be electrician multimeter. These meters are generally designed for much higher power, so to say, in terms of voltage, in terms of ampere. Basically, this can detect a very high ampere in terms of AC current. Basically, you put the conductor here, it was gonna show you very high ampere. Basically, you power draw of a air condition, electric heater, things of that nature. It will show that quite well. However, if you try to use this puppy to, let's say, measure current of a, let's say, LED bulb, it's not gonna do very well. It may just show like 0.001. It may not give you exact information. These things are designed for live work. Basically, high current voltage around 110 volt in case of Western worlds and 200 volts in case of everywhere else. So these things are designed for much higher oomph, but they are not designed to be very sensitive, because again they will get saturated if they try to measure high current, high ampere scenarios. So these is one type of category. You will see these puppy with people who are working with means voltage. Then there is another type of multimeter, the cheapest one in the universe. Basically, this one I'm reasonably sure you must have seen one variant or another variant of this. Whichever company made this, they must be a billionaire by now. So this sort of meters are designed for something bit different. They are designed for working on actual electronics. Basically, if you're not dealing with very high current, very high voltage, these things are quite suited for that. For example, let's say you want to work with Arduino, this puppy would be much better suited than this one. Even though on paper you may find, hey, this can also do voltage, this can do also ampere, resistance and all that, it's not suited for that. So these are the two main criteria, so try to be mindful of that. If you want to do just basic housework, this kind of meter is well suited to that kind of use, where you're just like once in a while. But if you're working on Arduino, Raspberry Pi, things of that nature, meters like this is much more suited to you. Now then we come to another aspect. Let's say you are like, okay, I'm gonna buy a multimeter. Let's look at the first thing that you will find. First thing you will find is people generally talk about ratings, so to say, in terms of count. So this puppy is what we call 2000 count meter. Everything is in steps of 2, basically 200 millivolts, 1000 millivolt, 20 volts, 200 volts, 1000 volt. Now 1000 volt is technically there for insulation reason, and this is what we call a 6000 count meter. You can easily find meters that have like around, give or take, 9999 count meter, or some places even more than that. But does that mean, what does that inherently mean? That inherently means one thing: it's just the megapixel of your multimeter. Yeah, I know it's a lame comparison, but that's the easiest way to understand it. Now, does that mean a meter that generally has higher basically megapixel, does that translate to better meter? Not necessarily. It's the same thing. 12 megapixel a mobile camera versus a 12 megapixel DSLR, you know for a fact that DSLR would be better. Same applies here. So you could find a scenario where, like, let's say a no brand meter has like 9990, while you buy a fluke one and they may like, okay, it's only 4000 meter. So again, if you want to rely on your meter, and especially if you are dealing with live circuits, because again, worst thing you're gonna happen with this kind of equipment is gonna waste some money and ruin your time. But if you mess up with this kind of thing, basically live wire and all that, you could actually injure or actually end your own life. So in those sort of scenario, people generally do try to avoid basically cheap equipments like this one. And the sole reason you can use this safely is simply because there is no insulation penetration. You are not probing something. So it's very good for ampere, but the moment you try to use these puppy for voltage, be mindful of that. Basically, there is a reason why flukes and other branded companies are so expensive. So that's the whole point. There is the megapixel aspect of it. Do not focus too much on that. Is it convenient to use it? Does it suit your need? Then go for it. But, and again, cost is also important, right? Because again, if everybody had more than enough money, most of the people will buy Fluke, because they really worked their ass off to create a basically recognizable name. So once you have the resolution, the another aspect that will frustrate you is basically range, and that's the sole point of these things. Basically 200 millivolts, 2000 millivolt, 20 volts and so on. So let's say you are measuring a 9 volt battery versus let's say 3.31. You may have to change your range. Basically, not only you have to turn it on, you have to fine tune which variable is best for that. So like I can try 2000 millivolt to read a 3.5 volt cell. It's not gonna do anything. It's not gonna measure it. And if I basically set it to 20 volt, I'm gonna lose resolution on lower one. So for that reason, this is the very cheap meter. So the moment you start to actually spend money, you will get meters like this, which will have very few basically positions, so to say. The reason for this would be they are auto select. What does auto select means? Inherently, you don't have to fine tune it. You just like here you have voltage ranges. Auto select meters do not have ranges. All they have is just what do you want to do. Basically, in this scenario, you have voltage, you have millivolts. Basically, if you want to improve the sensitivity, then you have ohms, hertz, ampere, milliampere, and things of that nature. You do not have to do too much other than that. So this will be saving your time. Like if you are experimenting with multimeter, you just want to, hey, can I actually use this? Is it something useful for me? Then I would urge you to try this, because again, if you do not use it day-to-day life, you're not going to be spending too much money on this. This is like barely $1 or $2 product. But if you are serious about it, like especially if you are working with Arduino, Raspberry Pi, 3D printer, CNC machine, you have to buy something like this, because more or less you have to rely on this, and you do not want to change. Basically, for example, resistors are the worst in this scenario. Like I have 3 resistors which I use quite frequently. This is 1 meg resistor. Then we have this is around 10 ohm resistor. This is 330 ohms resistor, and I have like a whole book of it, with each different 10 kilo ohm resistor. And again, resistors are much better if you buy them in bulk. So 1 kilo ohm. So this sort of scenario happens where you have too many range, and if you are using something that is manual select, you will be wasting your time doing that. Again, if your time is basically you are just learning out, or you are really strapped for cash, I can understand that. But again, if it's serious, if it's something that you are gonna actually do, please invest in something that has auto select. Thankfully, it's quite cheap in Western world, so that should not be too much an issue for you guys. So that's the whole point of getting a meter that has these advanced settings. Another aspect, people generally deal with LEDs nowadays a lot, even for something like Raspberry Pi or Arduino and all that. Then the problem becomes is like, how the heck you gonna know whether your LED works or not? Because many people used to try having a coin cell battery, which is 3 volt, and just directly connecting them. Now that's awesome for blue LEDs, white LEDs, awesome. The moment you did that with green LEDs or basically red LED, you're gonna roast them. So this is not a safe way of doing it. How would you do it safely? So generally, most multimeters will have a diode mode. LEDs are diode, so you can go into your multimeter mode and diode. Now, benefit of using a breadboard and using a lot of basically cheap multimeters, I have a lot of probes. Again, I did not bought extra probes, I just using cheap ones. Again, one probe I have which has an alligator clip. Sometimes these are useful, another times I utilize something like this. Now these probes are basically I've just soldered solder, so to say. LED leads to that. Benefit of this is now I can directly connect. Hopefully the full HD resolution is allowing you to see anything, and tada, now I can check each LED. Now here's the funny thing, because it's a basically what we call diode system, it's not gonna overvolt the system. So if I'm testing basically this is an infrared LED, it's showing me 1 volt. There is a very good chance it's dead. Now we're testing with red LED, the red LED is glowing, it's showing 1.9 volt, so I'm not gonna roast it. Now green LED, again 1.8 volt, so I don't think this is a very bright one. Yellow, 1.8 volt. So that's the whole point. That's why you do not want to use 3 volt cell. You're gonna roast your LED. Then we come to white one, 2.5. We come to white blue one, 2.5. Now this voltage is the minimum, basically how much voltage potential has to be there before current starts to flow. So that these are showing the minimum, not the maximum. That's why the maximum would be like around 3 volts or 4 volts or something like that. And even you can test this with like embedded LEDs and all that, so you can test out how they are working. Again, be mindful of polarity, because LEDs are very polarity sensitive, and this puppy is around 2.4 volts. So this is another use, especially for beginner electronics. Like if you're just starting up, like this is what I wanted to make this video about. It's like, this is something simple, this is something cheap, this is something that you can learn and begin. Like go into deep into this, as much deep as you want. Like go into a point where you're actually designing microcontrollers. But at this point in time, this is a very good affordable starting point. You can start with this, or even with this. Like this costed me around 1500 rupees in India, so these sort of things are quite cheap in USA and all that jazz. So you can start something like this, and this will make you much more electronically inclined, where you can actually understand what's going on, especially with these things, because again, it's inherently safe because you're not physically touching any conductor, and you can see, hey, your air conditioner is consuming way too much ampere. You're like, bro, there is a very good chance the gas is either leaked out or something else has happened. So you will hire a contractor before it's too late, before short circuit happens or something like that. So that is why people want to have this kind of equipment in their homes. Basically, you can check your water heater, big things, basically big power power load, this puppy is like, I got this, I don't have to. And you can even buy plugs. So if you do not have just like, you know, live independent, you have, because you have to put live inside, you cannot put live and neutral there, it will not read. So you have to put isolate the live itself, so the magnetic field does not compensate for each other. So for that, there are plugs you can buy which will allow you to directly clamp it, and you can read power outputs of anything. Or in some scenarios, if you have fluke or high reliability meters, you can utilize the another meter as a voltage system. Why? Because if you have too much load, there is a very good chance you are sagging the voltage. Basically, let's say 120 volts supposed to be the normal, and you generally get, let's say, 120 volt, everything is awesome. But the moment you put, let's say, 8 ampere load, you find out like, hey bro, the voltage dipping too much, is voltage is going to 100 volt, that means something bad is happening. So this sort of equipment is kind of useful in day-to-day life. Ideally, you should not want to use this as a like, okay, final tool. This should be like, you know, preventative measure. This should allow you to preserve your home, you know, and be more mindful of things that are happening here. Now, this meter that I'm specifying, these are quite cheap. These are like just as popular as this one. So I'm pretty sure you can buy something like this for around $1 or $2. However, this can only read AC amperes, not DC. Why? Because this is acting as a basically transformer core. It's just a transformer core, and you are inducing current into that. Awesome for AC, useless for DC. So you can buy meters, the clamp meters from almost all brand which has DC. However, be mindful, DC relies on direct sensing of magnetic field. There is no induction there because it's not AC. Side effect of that, it's getting affected by the Earth's magnetic field. So you buy a DC meter, it will always say please zero before measurement. So you put it in some awkward position because of how Earth's magnetic field are. It will already have a rating which will like 0.1. It will show some weird thing. Before you turn it on, you have to activate it 0. Or if the conductor is already live, basically it's already like a solar farm. People need this. Like, this is not a luxury for them. They have to have this which can read AC ampere and DC ampere. So for those people, it's quite important. So they will get as close as they can and then zero it out and then plug it in. So that way they can also measure DC meter. Now be mindful, meters come at like multiple cost. Primary reason for that, again, if they are not scamming you, the primary reason for that would be testing. Because again, this meter, while it does say cat 2, cat 3 and all that, I do not trust this. Again, I can easily put this in a live socket like this, and because I do trust this probe, I'm not gonna get electrocuted, but it's not something that I can trust. Again, if you have fluke, you are more likely to, because even if, let's say, some short circuit happens while you are testing it, which does happen, the meter is gonna get destroyed, not your hand, not your face. That is the primary reason CAT testing exists. CAT is like a insurance sort of scenario where people actually destructively test this thing. Like, okay, you said this is test safe for, let's say, 500 volts. They can actually put 600 volts and see how it destructs. Now, is it safe destructing, non-safe destructing? That's how they can get the rating. So to get that rating, you have to lose a lot of meters, then again pay the basically the firm that does the testing and all that. It's quite expensive. So that's why you will find many branded that are like, hey, in terms of feature they do not have too much, but in terms of cost they are ludicrously expensive. That's why. And if you are relying on basically high voltage circuits, basically 100 volt, 200 volt and all that, please go for those things, because cheaping out on some sort of like that, again, it's safe for ampere, but again, the moment you want to touch voltage with this, I'm like, dude, you're taking your life on your own hand. Again, you may be okay with that, because again, I have seen electricians utilizing this meter and they have lived for around 20-30 years. So be mindful of this. This is something very simple, very effective, and if you want to start with Arduino and all that, you're gonna need it sooner or later. And I would still urge you to buy basically this cheap one, simply because I use this one for only one thing. I set it permanently on what we call continuity tester. So because I do not like the idea of continuity being in like a sub menu. Like, who the hell came up with the idea? Continuity is the most commonly used system, and somehow continuity is inside the resistance and I have to press 2 times to get to continuity. That's quite frustrating. But again, different nodes. And not to mention, I also harness the probes out of it, because most probes are intercompatible. You can buy like cheap ones and like just have a different scenarios, where I have one probe that are like specifically for breadboard, another alligator clip based one which are specifically for inverter testing, 12 volt circuits and all that. It's specifically for that. And then I have another one which is, unfortunately, at the last moment, basically something like this, which is far more suitable for live testing, because again, the cable is not going to come out and you're going to electrocute yourself. The cheap ones are quite dangerous. So if you are doing mains testing, try to use quality probes which have like actual conductors, actual insulations, and there's a very good chance they're not going to end up destroying your life. And there is a reason why these slips are there. These slips are not a luxury option. It's like it's there so you do not accidentally, like even if you're holding like this, you do not accidentally slip. So if you're probing like this, you will not end up slipping and electrocuting yourself. So that's why, like, even if you have one primary meter, still buy a cheap one and just use it for its probes, or in my scenario, continuity testing. I like the for voltage and all, voltage and resistance. I use this simply because it has auto select, but for continuity, again, this is more than good enough. So this was my presentation on basically multimeter. I hope this actually allowed you to go into the multimeters and like, okay, I understand it. Let me try out, especially with low voltage, like 9 volt and camera battery cells and all that. Like, you're not gonna do too much damage. Worst case scenario is gonna waste your time. So again, say not for primary system, for primary home electrician, only this and only in current mode. Do not try to use these things, especially if you're buying something cheap like this. Now, there is one Banggood offering that is quite amazing for general everyday day to use. It also has AC current and DC current, and it also has auto select. This meter does not have auto range. This has auto range but does not have auto select. So basically I have to tell it, hey, measure in AC current or DC current, measure in AC voltage or DC voltage. Auto select meter can also select that part also, so you don't have to do anything. You just connect it, like, ta-da. So it's quite amazing in terms of feature, not in terms of basically safety and rating and all that, but as a good general day-to-day use. I will provide the link down below and you can check it out for yourself. Like, again, its Fluke variant does exist, but they're gonna cost an arm and a leg. So if you can afford that, and or if it's your day-to-day job, like you are working in a solar farm, investing in good equipment that will be keeping you safe and not to mention give you much higher reliability, much more confidence, it's gonna last you multiple years, it's a good investment. So this was my weird kind of trial of making another kind of video. Hopefully you guys liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I'd urge you to press dislike, press it twice to show me extra disappointment, and please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.